Okay, this is part 2 of the video. I said that we were going to pick up on the right side here, so let's get rid of that box that's covering everything up, and I'm going to do number 9 now. Like before, I've rewritten it here in standard form. I read across from left to right. I saw that 5 was my largest exponent, so I put that negative x to the 5th out front. And the next highest exponent was 2, so I put 3x squared next. And then, looking over these, if that exponent that's largest is 5, then the degree is 5. The lead coefficient is the number out in front of that first term, so that's going to be negative 1 this time. And there are 1, 2, 3, 4 terms in total. Again, the only names I need you to remember are monomial, binomial, and trinomial. Anything else you can just call a polynomial. So the only one up here that I need you to know a name for is this first one. 1, 2, 3 terms, so that first one there listed, number 3, is a trinomial. Next question from chapter 10.1. This time I'm just going to do one problem. I'm going to do number 12 for you here. They ask you to do it here in vertical format. On the test, I'm not going to insist on one type or the other. If you like vertical, great. If you like horizontal, that's fine too. On the next slide, I'll do a horizontal problem. Number 12 is a subtraction problem here. So the first thing I have to do is make sure that I've got these in standard form, and if I don't, I have to rewrite them, but I got lucky this time. 3, 2, exponent of 1, no exponent. So this one's in standard form, and then 2, 1, no exponent. Okay, so both of these are already, both of these are already in standard form. So I just copy that first one over there, just rewritten this down here, and I write the second one right below it. And I line it up. First of all, I make sure I note for myself this is a subtraction problem. 6x squared, well, that's going to go not under here, and in fact the first time I did this problem I accidentally wrote 6x squared here and I would have gotten myself all messed up. But x squared belongs under x squared, so I got 6x squared plus 2x going under the 5x minus 4 going under the 9. Now, I've said this a number of times, but I know it's worth repeating. Whenever it's a subtraction problem, I suggest that you change every sign. It just makes it a whole lot easier, so that becomes plus. Okay, so that's going to become a minus. Scribble this out. This is also going to be a minus. And that one's going to be a plus. Now that I've done this, it becomes an addition problem, and it's a whole lot easier. So I've got negative 4x cubed. Let me go back to my, there. Negative 4x cubed in that column, minus 8, minus 16. If I've got negative 8 and then another negative 6, together they make negative 14x squared. Positive 5 and negative 2 make positive 3x, and positive 9 and positive 4 make positive 13. And that's my answer. This time, as promised, I'm going to do horizontal. Once again, it's a subtraction problem. So what I have to do when I do it horizontally, and again, this is only if you want to learn how to do horizontally, I have to find matching terms. Well, matching terms, again, it means that the variable is the same and the exponent's the same. So I'm looking for, in this case, something that matches t squared on the right side. And there it is. Okay. So the first thing I'm going to write down, yep, the reds are going to match. Are these t squareds matching up? Notice that the ones I've underlined in blue here also match, t and t. I don't know why I made a mistake, I guess. I didn't underline that in purple over here, but the 2 and the negative 7 match. So I put the reds together first. And I'm going to have, let's just do it all the way out and you'll see everything. I'm going to have 3t squared minus 3t squared, because there's a minus and another minus. Make sure you don't lose one of these two negative signs or you'll get yourself all messed up. In the blue, I'm going to have negative 8t and I'm going to have minus positive 5t. So it's negative 8t minus 5t. And lastly, in the purple here, 2 minus 7. 2 minus 7. Okay, so what do these things form together? 3t squared minus 3t squared, that's really 3t squared plus 3t squared. or 6t squared. Negative 8t minus 5t is negative 13t, and 2 minus 7 is really 2 plus 7, or 9. So cleaning it up, that's my answer there in green. 6t squared minus 13t plus 9. Alright, now we get into the multiplication in lesson 10.2. I'm only going to do one problem, question number 10. And the way to do this is a distributive property problem. I taught this to you some point in the late fall, early winter. If you've got one number or one term, in this case, on the outside and a bunch inside parens on the inside, then you distribute it to everything inside. So I'm going to do the blue, then the red, then the purple. The blue is 3x squared times 2x squared. The red's going to be 3x squared times minus 4x. And the purple's going to be 3x squared times minus 7. And there they are, all written out. 3x squared times 2x squared. 3x squared times negative 4x. 3x squared times negative 7, just like I said up here. Okay, well, let's reorganize this. If I've got a string of numbers, like I do in blue here, that are all being multiplied, I can change their order. It doesn't screw up the problem. So I can put the 3 next to the 2, and I can put the x squared next to the x. And that's what I do here. Let's do it this way. 3 times 2 times x squared times x squared. Similarly with the red, I'm going to put the negative number out in front of the positive number. Otherwise, I might think it's a subtraction, and it's not. So it's negative 4 times 3 times, there's that x squared, there's that x. And the last one here, again, I've got a negative, so I'm going to put it out in front of the positive. Negative 7 times 3, negative 7 times 3 right there. All right, now let's just do the work. 3 times 2, that's 6. And x squared times x squared, remember, I add the exponents. So in each case, I've done the work here. Negative 4 times 3 is negative 12, and I'm adding these two exponents, 2 and 1. All right, well, now I clean up the last pieces. 6, x to the 2 plus 2. 6x to the 4th. X to the 2 plus 1 becomes x cubed. This in green is my answer. Anytime you want to hit pause, double check, make sure you've got number 10 solved the same way I do, and that'll help you to go back and look at the other problems that I've asked you to do from this section. Oh, and by the way, when I say that, I want to repeat something I said in class many times. You do not have to do all these problems. What I want you to do is keep doing problems until you're very comfortable with a particular type. Once you're comfortable, move on to the next section. Speaking of next sections, the next task and the next lesson you guys received was how to use the FOIL pattern to multiply. FOIL only works when you're multiplying two binomials. There's a binomial on the left and a binomial on the right. Remember, binomial means two terms. So there's a two-term expression on the left and a two-term expression on the right, and you're multiplying them. First, outer, inner, last. That's what FOIL stands for. First means 2x times x. Outer means 2x times 8. Inner means negative 2 times x, and last means negative 2 times 8. So that's exactly what I've written here. Then 2x times x becomes 2x squared. 2x times 8 becomes 16x. And so on down the line here. Remember, I said with FOIL that the middle two terms, at least for what we're going to be studying for now, are always going to match. So I can combine these middle two terms. 16x and negative 2x become 14x. So my final problem just has three terms. It's trinomial, and FOIL patterns will always lead to trinomials. And there it is, the answer in black. Then you were supposed to match a trinomial with factorization. And I did this, I don't really do all 6, but I don't want to give away some of them and tell you you only have to pay attention to some of these. So I'm going to do the first, I'm actually going to do 3 and leave you to do the other 3. Let's start with looking at all 6 of them together, and what I notice, let's find something that's different about them. And the thing that I notice is that question 6 ends in 9. Well, remember how factorization works. 9 happened because something times something multiplied to make 9. And that's what I'm saying here. The lasts in the FOIL pattern, those lasts multiplied to make 9. So then I look over here to the right and I try to find some lasts that multiply to make 9. And when I look at it, I notice C, that negative 3 times negative 3 does multiply to make 9. So C is my answer for number 6. Same kind of thinking. For number 5, I notice that 4 is the final term, and there's nothing else here that has a 4. So there's got to be one answer over here where the lasts multiply to make 4, and that's A. Negative 2 times negative 2 does multiply to make 4. So I can cross those two off right away, and that's what you're looking for when you're given a list like this in a matching game. Find something that's different that makes one of these unique. And this 9 here makes number 6 unique. This 4 here makes number 5 unique. And if you can get those off your list pretty quickly by noticing that negative 3 times negative 3 makes 9 and none of the other lasts do, then there's only one answer that matches number 6. And that's how I did 5 and 6. The last thing I had to do then, let's get rid of this. Alright, the remaining 4, 2 of them end in 6, 2 of them end in negative 6. So let's just look at the first 2 here that end in 6. Well, number 1 is one of those ones. So the lasts have to multiply to make positive 6. There are 2 different situations where that happens. D and E both do that. Negative 3 times negative 2 does multiply to make positive 6. Positive 3 times positive 2 also does. So which answer is it? Is it going to be D or E? So now I look at, all right, what's the difference between 1 and 2? They might both end in 6, but the middle term here for number 1 is negative 5. Okay, well that means the inner and the outer are going to combine to make negative 5. The only case where that's true is D. For D, I've got negative 3x for the inner and negative 2x for the outer. So D is the one that matches number 1. I've done 3 of these. I'd like you to do the other 3 to finish that off. I'm going to stop the video here and make one more that I hope will finish off everything we have to do.